I made so many mistakes on this question. So many silly, small, teeny weeny mistakes. Of course on purpose, so that you can see where the silly mistakes might happen. But it's all about differentiation, optimization questions. They're on purpose so that when we practice it, we don't make that same mistake again. So I did it for you, so you don't have to do it for yourself. You're welcome. You're welcome. Let's get into the question. ABCED is a five-sided shape. ABCD is a rectangle, and CED is an equilateral triangle. Okay, so before anything, let's just try the variables on our diagram. So if it's a rectangle, if this is X, then we know that this is also X. If this is also Y. Now, because it's an equilateral triangle, this is X. These are all equal, so X, X, and X. Okay, so let's just get that out of the way. Now, it says here the perimeter of ABCED is 100. So let's start with that. So the perimeter of ABCED, so they're talking about the whole entire diagram. So that's going to be 3x plus 2y equals 100. Okay? Now, the next piece of information that they give us is that the whole area, so the area of ABCED, so the whole thing equals R. So let's just write that over here. So R is equal to the area of the rectangle plus the area of the triangle. Okay, now let's put in the information that we have. The area of a rectangle is base times height, so that's just going to be x times y plus the area of the triangle. Every triangle is a half base times height, so we've got a half my base, which is x, times my height, and I don't have my height just there, so my height is the perpendicular height over here, h, so times h. Now we look at this question over here and we see you only have it in terms of x's, so let's find out what our h is. So I'm just going to grab that over there. We've got a right triangle over there where you've got x on this side, h, and then the base over here is a half h. So if I just redraw that over there, my height, I can use Pythagoras to find my height. So my height is the square root of x squared minus a half x all squared. Now be careful of this, that you're squaring the whole of it. You're squaring a half x and not just putting the square on the x squared outside. Okay, so if I simplify this further, I will get the square root of 3 over 4 x squared. And I could also write it as this, 3 over 4, square root of 3 over 4, and square root of x squared. So I end up with square root 3 over 4 times x, because the squared and the square root cancels out. Ooh. Okay, I could also simplify that a bit more. If I've got the square root of 3 over 4x, that's the same as square root 3 over square root 4. X square root 4 is 2. So I could just write it as 3 over 2x. Okay, so this over here is my h. Now let's replace it in the equation. So I've got h here is going to be plus 1/2 x, and instead of h, I'm going to replace that with square root 2x. Now, notice over here, if I look back at xy, so I've just done this, it's all in terms of x, but if I look over here, I've got a y, and when I look at the show that, I don't have a y. So let's rearrange my equation over here, 3x plus 2y, to make y the subject. So if I make y the subject, so I get y equals 100 minus 3x over 2. So now we're going to replace this y with this y. So let's rewrite that, equals x times 100 minus 3x over 2. Okay, plus the rest of the equation. A half times root 3 over 2 would give me root 3 over 4. So root 3 over 4x. Now we've cleaned it up. Let's see what it has. It wants us to show it in this form. Notice the clues in this question. One of the clues is that it's all over 4, right? The other clue is that this is 200, but you've got 100 over there. So those are giving you tips and tricks on what the question actually wants you to do. So let's expand it first. R equals 100 over 2, and I'm leaving it like that for a second, x minus 3 over 2x squared plus root 3 over 4x. Now, why did I do that? Because if I look at the denominators now, I can make them all over 4 so I can get it into this form, right? So to make this over 4, that's 2 times 2 times 2. So I'm doing it just a longer version, but just so that you can see where it's coming from. So r equals 200 over 4x minus 6 over 4x squared, and you've already got the root 3 over 4x. Now notice I'm starting to see all these numbers, the 200, the minus 6, the 3. Now, if I just factorize out the x over 4, I'll end up with what they're asking me. So r equals x over 4, and inside my brackets, I end up with 200 minus 6 plus root 6 plus root 3x. Actually, there is something I forgot. If you look over here, what did I forget? I did 1/2 times root 3 over 2x, but I forgot times the x by 1, the other x. So this is squared. Yeah? So if I factorize out, that's... And now, my final answer, I get r is x over 4, 200 minus 6 minus root 3, x. Yeah? Okay. Right, so now let's look at part B. Okay, usually part A is all like the algebra part, formulas and all of that. Part B will be some sort of differentiation. So let's have a look at part B. It says, find the value of x for which r has its maximum value. If we're talking about maximum value or we see the word minimum value, what do? We differentiate. So a maximum value, which is like a stationary point, a maximum point, dr over dx is equal to 0. That's what this tells me. Okay, and a maximum point looks like this. If I was going to draw this curve, this is my maximum point over here. So dr over dx equals 0. Yeah, so the first thing I need to do is differentiate. Now notice part A is a show that question. Even if I wasn't too sure about doing part A, what's happening with my thing? Even if I wasn't sure about doing part A, just from this show that part, I can use this to answer part B, okay? So if you feel like you're spending too much time doing that, you could do part B and then go back to part A after that, okay? So show that R equals this. Let's use that over here to answer this question. So I'm just going to rewrite it. We have R equals x over 4, 200 minus 6 minus root 3. X, okay? Now I need to get dr over dx, okay? So before I do that, let's just make this nicer for me to be able to differentiate. So r equals, open up our brackets, you've got 200 over 4x minus 6 minus root 3x over 4. Now let's simplify this. I get r equals x squared. So I end up with 50x minus 6 minus root 3 over 4x squared. Okay, now let's differentiate. So dr over dx. So this x you got 50 and multiply by the power, take one away from the power. So if I multiply the power, it's going to be 2 over 4, which will leave me with 6 minus root 3, and it will simplify into over 2. Now we know that a maximum point, dr over dx is 0. So 0 equals 50 minus 6 minus root 3 over 2x. And it's much nicer for me to bring this over to the other side to make it positive. So let's write it as 6 minus root 3 over 2x equals 50. I'm going to look back at the question to see what form they want it. They want it in this form, okay? Where is my clue in this? That I don't have a divide by 2. I've just got it as it is. So the first step is let's get rid of the divide by 2 by multiplying both sides by 2. So we end up with 6 minus root 3. X equals 100. And now I've literally just answered it. So x equals 100 over 6 minus root 3. And this, my friends, is the final answer. So 100 over 6 minus root 3. Does that mistakes that could be made are the mistakes that I made as well. Dropping the X, obviously I'm doing it in a rush, but dropping an X, you just have to be very careful with these questions. But also, as you go along with it, if you've made like a small mistake, you can tell when it comes to the answer, because you might just find that you just end up with something that looks different to this form. Okay, so when you're doing these questions, take your time with it, because it's the small algebraic stuff that could make you lose marks. Now, the final part is explaining why the maximum value of R is given by this value. Why? If we look at R, if I was going to sketch R, what kind of shape would this give me? What kind of equation is this? First of all, you have to say that this is a quadratic parabola. And then how do you know that it's going to be an NR negative? Therefore, you will have a maximum point. If it was a positive x squared or a positive quadratic, what would you have? Would you have a maximum point, or what kind of point would you have? Point. Okay, makes sense? Sometimes this works. Yeah, perfect. Not perfect. That's much better.